Hello everyone. Today our group will present a journal Achieving Framed Autonomy in AI Augmented Business Process Management Systems through Automated Planning. Our team consists of Andaru, Mirza and Andrea. My name is Julius and I will start with the journal. Now to the challenge. Traditional business process management systems are often too strict for real situations. In real environments, unexpected events can interrupt the normal process flow. This is especially true in areas like healthcare, emergency management, or retail. When something unusual happens, fixed workflows may not be enough to guide the next steps. Now the solution. The paper introduces framed autonomy as a solution. Framed autonomy means that an AI augmented process system gets the freedom to adapt the process, but only within safe boundaries. These boundaries are defined by procedural rules and declarative rules. If conflicts appear, the system tries to choose the option with the lowest violation cost. In simple terms, the system becomes an intelligent assistant that can find the best possible path even in complicated situations. This journal was published in Information Systems in 2025. The authors are Giacomo Acitelli, Antti Alman, Fabrizio Maria Maggi, and Andrea Marella. They use a formal scientific method. They build a complete mathematical model of the problem and then test the technique with experiments to see if it works on large and complex process models.
Hello everyone, my name is Samuel Kamadana and I'm going to talk about the AI as a decision support system and in our journal where intelligent decision support that has been revealed the system function as a sophisticated DSS or decision support systems where it supports semi-structured decision making by acting as an intelligent agent where the system itself analyzes the current process that states against the model based of constraints and use AI as an inference engine to recommend the optimal path forward. Continue on the slides that I'm going to discuss. It's about the hybrid process representations or HBPR, where as you can see here, there are several modeling frames where to achieve the autonomy that we want to use, the system itself combines two types of logics, where the first one is it discusses about steps or procedural logics, where it defines the standard workflow steps, such as standard clinical guidelines, as you can see here from AP and then PS. And then for the second one, declare or as equivalent to declarative and use liner temporal logics or LTLF to define safety constraints such as drug must never differ from drug. It's a system where it differentiates between them. This hybrid method allows the systems itself to understand both what should happen and what must not happen. These are the methodology about the systems developed for the transformation process. The first one is the input itself, where the system just vertical models, the pertinence and the LTLF, and then it converts it into all constraints that are automatically transferred into DFA or distributed finite states of it. And the third part is where DFA itself state navigation is being reduced to an AI planning problem, indicating a path forward on start to go. And then the last one, of course, is going to be executions that generates the solver itself cost optimal execution trace that minimize fuel coverage.
Okay, so this is the planning engine. So the core engine uses a planning domain definition language. It treats the business process as a search space. The main goal of this is to find a sequence of actions that transitions the system from an initial state to a final state, which is valid. And this planner includes special violate actions, allowing it to break rules if necessary, but forcing it to choose the path with the minimum penalty cost. And there are a few problems with the planning. So the first one is the domain. The how we solve that is to define the combined states of all the automatons, the automatic procedures, the DFA, the declarative DFA, and also the prefix trace. And the goal is to reach a system set where all components are in their respective final or accepting states all together simultaneously. And the solver is the author utilizes fast downward planner, a standard high performing AI solver, to calculate the optimal path. And the experimental performance, so the scalability using the declarative automatons is very excellent. It handles tracing very well, but using complex petri nets is quite a bottleneck, so it's not that efficient. So the solution is to scale efficiently with rule complexity, but facing performance bottlenecks when underlying the procedural model, which is the complex petri nets that contains massive numbers of acyclic paths. So the main insight of this research is the how to transform a compliance problem into an optimization problem. So we need to find the least costly, the most efficient way to complete a process. And to conclude, it's quite a robust solution. The automatic processes, they successfully bridge the gap between rigid models and flexibility using AI for planning. And some recommendations that we suggest is to incorporate data attributes and timestamps to support more realistic constraints so that they can view the data in real time. And then the second is to develop a much more dynamic cost functions that adapt based on context rather than using unitary costs, so they can adapt to the situation that they're currently handling. And that is all from us. Thank you for taking the time to listen to our presentation. If you have any questions, please put it in the comment down below. And these are the references that we use. Of course, we use it from the article that we got from the journal, and we also take one of the presentations from week 11. I believe it's the managing knowledge and artificial intelligence in the classroom as well.